Okay, AP Calc BC kids. So this lesson is going to be on the integration technique of partial fraction decomposition. Now you have decomposed fractions before. So just to remind you, let's say you have 5x minus 3 over x squared minus 2x minus 3. You would make this 5x minus 3 over x minus 3 times x plus 1. And then you would take 5x minus 3 over x minus 3 times x plus 1. And you would set this equal to a over x minus 3 plus b over x plus 1. Okay, so then you would multiply everything through by x minus 3 times x plus 1. So you would end up getting 5x minus 3 equals a times x plus 1 plus b times x minus 3. So then what you would do is you would let x equal negative 1. If we did that, we'd get negative 5 minus 3 equals b times negative 4. Negative 8, negative 4b, b is 2. And then if we let x equal 3, we would get 15 minus 3 equals a times 4. 12 equals 4a, so a equals 3. Okay, therefore, 5x minus 3 over x minus 3 times x plus 1 can be decomposed into 3 over x minus 3 plus 2 over x plus 1. Okay, what does this have to do with integration? So if I asked you to integrate this dx, you would instead decompose and integrate this, which would now become 3 times the ln of absolute value x minus 3 plus 2 times ln absolute value x plus 1 plus c. Okay, let me show you the ln part. The ln part comes from u sub. U equals x minus 3, du equals dx. So for the 3 over u part, du, I get 3 ln absolute value u, which is 3 ln absolute value x minus 3. Then for the x plus 1 part, I have u equals x plus 1, du is dx. So I get 2 over u du, right? Which is 2 ln absolute value u plus c, which is just 2 ln absolute value x plus 1 plus c. Okay, so that's where this came from. Okay, so take a look at example 2. Number 1, I have to factor this. Okay, you have to check, make sure it's not arc sine, not arc tan. You have a hierarchy of methods. Okay, and I teach it in the order of the hierarchy. 1 over 3 minus x. Okay, times 3 plus x. So now I'm going to do my partial fraction decomposition. Okay, so multiply the entire thing through by 9 minus x squared. So we end up getting 1 equals a times 3 plus x plus b times 3 minus x. Okay, let x equal negative 3. Let x equal 3. We get 1 equals negative 3 minus negative 3 is 6b. b is 1/6. If x equals 3, we get 1 equals 6a, a equals 1/6. So we get the integral of 1 minus 9 minus x squared dx equals 1/6. And then another 1/6 for the b part. Okay, you can factor out this 1/6 out in front of the entire thing. Just make it easier. Now, with the u substitution, you have to be careful here. Because if I make u equal to 3 minus x, I get du equals negative dx. So dx gets replaced with a negative du. So I have 1/6 times the integral of 1 over u du, but it's negative. For the other integral, okay, you could see that that's straightforward. So du is dx. So I just have du over u. So that is 1/6 times negative ln, absolute value 3 minus x, plus ln, absolute value 3 plus x, plus c. So this ln part, okay, keep in mind, I can take this negative and bring it up. I can think of this as 1/6. Let me change this order. Ln absolute value 3 plus x plus ln absolute value 3 minus x to the negative 1. Or just think of properties of ln that if I subtract ln, it's the same as dividing the ln's. So I get 1/6 ln absolute value 3 plus x over 3 minus x plus c. Now, when you look at this question, you may want to start off by thinking, oh, I'm going to make this a u sub, right? But then when you go to make it a u sub, you would end up with u equals x squared minus 2x minus 8. So you'd get u equals 2x minus 2. So that doesn't match. Okay. You could make it separate fractions. That's not really going to help. So the technique we're going to use here is going to be a partial fraction decomposition. So I have 2x plus 1 over x minus 4 times x plus 2 is a over x minus 4 plus b over x plus 2. Multiply everything through by x minus 4 times x plus 2. So then we end up getting 2x plus 1 equals a times x plus 2 plus b times x minus 4. Let x equal negative 2. Let x equal 4. Okay, if it equals negative 2, I get negative 4 plus 1 equals b times negative 6. So that is negative 3, negative 6b, b is a half. For x equaling 4, I get 9 equals 6a, so a equals 3 halves. So my new integral is a, 3 halves, times 1 over x minus 4 dx plus b, which is 1/2, 1 over x plus 2 dx. So that's 3/2 ln x minus 4. You could try the u sub on the side. You'll see that the u sub, because it's the x has a coefficient of 1, it's not going to be a problem. 1/2, and then ln x plus 2 plus c. You don't want to forget the plus c. Okay, so you may want to stop the video and try this question and come back and check it to make sure you're on the right track and that you get what's going on. So I'm just going to factor it. So I get a, x plus 5, b, x plus 1. I multiply through. X plus 5 times x plus 1. So now we just have x plus 3 equals a times x plus 1 plus b times x plus 5. So we're going to let x equal -1, let x equal -5. So if x equals -1, we get 2 equals 4b. So b is 1/2. If we let x equal -5, we get -2 equals -4 times a, so we get a half again. All right, so our integral x plus 3 over x squared plus 6x plus 5 dx becomes 1/2. Now I'm going to leave the 1/2 factored outside since a and b are the same. So I get the integral of dx over x plus 5, and then the integral of dx over x plus 1. So that just ends up being 1/2 ln absolute value x plus 5 plus ln absolute value x plus 1 plus c, and we could just write this as a product. Ln absolute value x plus 5 times absolute value x plus 1 plus c, all divided by 2, right? And I can just leave this plus c factored outside. It's easier that way. Okay, that concludes this lesson. Thank you very much.